people who've made enormous contributions to our field. We award several awards across different age brackets, seniority brackets, I don't know. So today we're going to have the EPS Prize Lecture, and that's given to people who have made a great contribution to our field within the first several years, I won't embarrass you, of their careers. Okay? So this is Nadine Lavan, and as you will have heard this afternoon from the many great lectures we've already had, she's made a huge contribution in our understanding of voice perception and other areas. So she's published extensively, I think 40, or maybe more now. 40 is a lot, right? And she's not, she's receiving this illustrious prize today, but she's received loads of prizes in the past, although this must be your highlight, surely.
Favourite one so far.
Favourite one so far. So just a little bit of background on where she's come from. So she received her BA in Linguistics and Phonetics, is that right?
Kind of, yeah.
My handwriting. At the University of Cologne, and then she moved to do a master's at UCL in cognitive science, and then a PhD at Royal Holloway in 2017. Is that right? So she's currently a Sir Henry Wellcome Fellow, and as you know, for psychologists, these things are like hen's teeth. So it's a huge fillet in your and the Society's illustrious history of people who've won this award. That you have a Sir Henry Wellcome. It's brilliant. You're going to get another one afterwards, presumably.
Trying.
Anyway, so without further ado, I'm going to ask Nadine to start her talk, and I want to give you a round of applause.
Thank you. Okay. Well, hold on, I can't move, so I need to stand here so you can hear me. Okay, well, thank you so much for this lovely introduction, and also thank you for the prize. It's really great, and what a treat. And also, of course, to the people in the symposium, thank you for coming. Thanks for presenting your wonderful research. A really, really great symposium. But now it's my turn, oh God, and prize lecture time, wonderful. So I'm going to talk about some of my work on person perception from voices, and in this talk I'll basically try to take sort of a few bites out of the big research question, or the big question of how do we actually make sense of who we're talking to when we are hearing their voice. And I am a voice researcher, so I'm biased, but I think voices are a really interesting thing to study, because as soon as we hear a voice, it's just such a rich and salient signal. We hear a voice and a lot of information that we can decode or evaluate just flies at us. And the first thing usually that flies at us in terms of information when we hear someone speak is, what are they saying? What is the linguistic meaning of the words and sentences people are saying to us? And we're really good at decoding this kind of stuff. Emma has been talking a little bit about that already. And loads of information can be found in what is being said. But that's in no way where it stops in terms of the information from voices. There's also information to be gleaned in how we say things. By listening to how someone chooses to speak, we can tell whether they're joking, whether they're being serious, whether they think a situation is a formal one or they're treating it as informal. Loads of stuff we can get out of how someone is speaking. And then, by no means finally, but another big sort of source of information that we can get out of voices is who is talking. A voice comes out of a person. That shapes what your voice sounds like. That person will have intentions in conveying information to you about who they want you to think they are. And this is all stuff we infer from voices. And of course, my title might have given it away already. This is the kind of information we're going to deal with today in this talk. Who is talking? Who is talking? Anyway, the talk comes in two broad parts. In the first part, I'm going to look at identity perception from voices. So looking at people specifically recognize a certain specific person and how they become familiar with a person and learn to recognize them. And the second part of the talk, I'm going to kind of zoom out a little bit and think about more broadly person perception from voices. So beyond identity, what kind of other stuff about a person can we get from voices when they come to our ears? Okay, first part, identity perception from voices. All of the studies I'm going to talk about today in some way are based on this observation here. voices, as we counter them in our daily lives, are extremely variable and extremely flexible. And I'm going to try to convince you that the statement is true by just playing you 4 short recordings of a person. And as you can see on the slide, these 4 recordings are all from the same person. So give that a listen.
Hello, everybody. It takes so many people to do what we do.
Last year, you guys helped me raise $27,000.
Yeah, no facial hair for you.
I don't actually know what the context of that statement was, but hey, here we go. Anyway, 4 recordings of the very same person. And this person these are just clips taken from different interview and sort of video clips you can find of YouTube of a person. I didn't select them to make the voice sound different. This person didn't intend to sound different from clip to clip, but you can hear in one clip the pitch of the voice is low, in the other one it's high. The speaking styles change. Voices are variable. We change our voice to imbue it with all of this information that we try to convey, and yeah, that makes them just acoustically variable. So, voices are variable. I hope I convinced you of that. But here's the thing, we're talking about identity perception. And while voices are variable, identity is stable. No matter what I do with my voice, no matter how all over the place it is, I'm still just me. And if you, as a listener, try to work out who I am and perceive my stable identity of my variable voice, well, it's going to get kind of interesting, isn't it? So that brings us to the first sort of research question that I'm going to talk about in this talk, which is, what does this vocal variability that we just kind of experienced do to identity perception? And I'm going to present a little bit of evidence here from voice sorting tasks. Now, voice sorting tasks, for those of you not familiar, is something I sort of kidnapped from the face perception literature, where there are face sorting tasks. They work in a very simple way. People get a stack of images of faces and are told, here's some faces, sort them by identity, and they do that. Now, if you want to do this kind of thing for voices, it gets a bit tricky, because have you ever tried to hand someone a recording of someone? That doesn't work. So we needed to kind of adapt the procedure a little bit. And the way we went about this, do I have a mouse? I do. Right, we literally did what you see on this slide. This study runs in PowerPoint. Essentially, you can see here on the slide are 30 numbered boxes, and behind each of these boxes is a little sound. Now, if you're in PowerPoint and not in presentation mode, you can click on these sounds and thus hear the different voice clips. And PowerPoint is a perfect drag and drop interface. So if you do then give participants the instruction, here's some recordings, please sort them by identity, they can go around and make clusters where all of the recordings of something that belongs to, the recordings that belong to one identity according to their ears can be put into one cluster, and then next door you might create another cluster where people basically sort the recordings that they think belong to another identity. So that's how the principle of the voice sorting task works. I should tell you a bit more about what these sounds are, these recordings of people that were included here. And there's 30 boxes, so we've got 30 variable recordings extracted from a TV show. Variable because we're looking at the effect of how vocal variability essentially affects voice identity perception. And what I mean by that is just literally sound clips taken from different scenes. They're not controlled for the linguistic content, for the speaking style, for the emotional content, just voices as they happen to vary when we use them in our daily lives. These 30 variable recordings come from 2 different identities that are in this case unfamiliar to our participants, and each identity is represented by 15 sounds each. And here are some examples of what they sound like, pretty much like the ones you just heard in the little demo I did in the previous slide. But here they come.
This is what's happening.
We deserve to know.
No, I can get out of my own car.
So these are the kind of recordings that people were sorting on the slide. Now, if people were doing this task perfectly and they were super accurate, this is what we would want to see. 2 clusters, 15 recordings of those identities in each respective cluster. That would be perfect performance because we've got 2 identities present. Let me show you what participants actually do. These are representative sorting solutions that my participants have produced, and you can see they do something quite different to the 2 clusters that would be the ideal solution. They form many, many more clusters. They perceive many, many more identities than are actually present. In fact, if you go counting, the median number of perceived identities here is 8 instead of 2. it's not really good performance, is it? So people were actually quite bad at this task. So as a kind of preliminary answer to our question, how does variability in voices, because all we did was give people variable recordings, affect voice identity perception? Well, vocal variability really seems to disrupt identity perception. Things have not gone well here. People are bad at this task as soon as they encounter variability. And if you look at how these clusters are formed, people are like randomly thrown clusters or sounds into clusters. There's like something very specific and systematic going on in how clusters are formed. Because listeners can't seem to make sense of the same person sounding different across two recordings. They hear one sound of one person go, cool, that's one person. Then they hear the same person again in another sound going like, yeah, that sounds different, must be different. So in the end, listeners perceive one identity as many different people, and to borrow again a term from the face literature, people therefore fail to tell the identities, the different recordings together. Interestingly, listeners only very rarely perceive the two separate identities as one. So mixing errors where two identities get mashed together into one perceived identity happen very rarely. So listeners are good at telling people apart. And this happens, by the way, no matter how well you match the voices on demographics and acoustics. Just people don't seem to do these telling apart errors. But listeners were bad at this. When we go through our daily lives, we're not constantly confused by sort of a sea of voices that constantly change and where we can kind of make sense of voices most of the time when we encounter them. And there are many reasons for that in a non-voice sorting setting, but in real life. But one reason is that sometimes we meet familiar voices and we know these voices already. So we essentially, in the next bit of this study, or in another condition of this study, asked, well, people were terrible at this. This isn't good. How can we make them better? And we were just like, okay, what does familiarity with a voice actually do to this? And how does familiarity maybe help people deal with vocal variability? And for the keen-eared among you, or the people who have watched Breaking Bad, the two characters that were featured in this voice sorting slide were taken from the TV show Breaking Bad. Breaking Bad had just finished a year or two before I ran this study, so there were a lot of people around who had watched quite a lot of Breaking Bad recently. And with having basically clips from a very popular TV show, we could record two kinds of listeners: people who had never watched Breaking Bad and they were then thus effectively unfamiliar with the voices. They also didn't recognize these people from any other show. And to get our familiarity manipulation in and test people who were familiar with these voices, we could get people in who had watched Breaking Bad at least one season. So they knew these voices. And here's what happens then if you let these people loose on the voice sorting task. This is the old data that you've just seen, people who were not familiar with the voices. This is what happens when people are familiar with the voices. I didn't even bother to plot the data because it's so obvious in the individual solutions. Basically, people are just doing something entirely different in terms of accuracy and performance, and we see that people suddenly can cope with variability and form these two clusters with little bits and pieces where there's like individual sounds that they can't quite integrate into the clusters, but that's voice perception for you, errors everywhere, basically. But essentially, if you go counting again, the median number of perceived identities is now 3, which is much, much, much closer to the accurate kind of solution. So revising our initial conclusions about vocal variability and identity perception, yeah, vocal variability is probably always going to be a challenge, but this is especially true if you are not familiar with a voice. Then vocal variability really throws you, and you think everything that sounds different is going to be different people, and that's how you're going to deal with this task. If listeners are familiar with the voices, they can suddenly quite well cope with this within-person variability, and voice identity perception actually becomes really rather accurate. And might seem obvious, but if you think about it, it becomes less obvious in a way, because to go from an unfamiliar voice to familiar voice, well, every familiar voice started out as an unfamiliar voice. So the voices haven't changed, it's something in the listeners that has changed. And I'm sure a lot of things happen when you become familiar with a voice or familiar with a person. But one of the things that does happen is that listeners do then, when they experience a voice over and over again, they start to form a representation of what that voice sounds like, a mental representation, and they can then, when they hear this voice again, tap into that mental representation and thereby recognize that voice as familiar. So that leads us to the next part, or is it our next research question, when we become familiar with a voice, when we go from unfamiliar to familiar, how do we form these representations, and how particularly do we form them from variable voices, because variable voices is what we encounter in everyday life. And in a very minimalist way, I'm summing up here like decades of research, probably summing up badly as well, but there's two broad schools of thought about how mental representation or category representation might work. One school of thought thinks we experience things, in this case voices, and we're kind of storing the exemplars, and that kind of makes up our representation. Another school of thought thinks that we hear things and then do something abstractionist, or like boil things down to salient cues or summary statistics, and then we build our representations of these kind of more summary statistic on these summary statistics, and averages or kind of averages have often been implicated in what might be abstracted. I am not going to trade off these two things against one another. There's too much work, but I'm going to focus in on basically the specific question of whether we can find any evidence of averages being abstracted when we learn to recognize unfamiliar voices and when we become familiar with them. So what we did there in this study was to do a lab training study. So the general approach was that listeners came to do our experiment, and they were trained to recognize a bunch of voices based on a distribution of variable signals, because we're still interested in vocal variability, and we're also interested in averages, and if you have no variability, well, your average is everything you have. So we're training people on a distribution of variable voices, and then after training we test them on how well they learned the individual voices. And I should say, while there was natural within-person variability and people dragging things around on a slide and everything was very unconstrained in the sorting task, this is kind of the opposite. This is a highly controlled and constrained task that we opted for. So we just had a lot of experimental control over what we were doing. And we could then make a prediction, a prediction where we could say, well, if the recognition accuracy is higher a test for the average of that training distribution, we might have some evidence on our hands that averages would be abstracted. Now let me talk to you specifically what we actually did in the training. We came up with this acoustic voice space that all of our voice identities lived on. We created different voice identities by doing acoustic manipulations of them and creating distinct sounding voices. Our voice space, you met these acoustic properties before in several talks, was determined by the fundamental frequency of voices, which correlates to pitch in perception, and formant spacing, which is kind of something about the overall voice quality. So we've got this two-dimensional acoustic space. And during training then, our listeners were trained to recognize a bunch of voices on sort of ring-shaped distributions that you can see here on the screen that were crucially missing their centers and averages. So we've got a 2D acoustic space, we've got these ring-shaped distributions. Each little circle here indicates a stimulus, and that's what people were trained on to recognize these three voices. So that's the training, weird square ring-shaped distributions. A test then, listeners experienced this ring-shaped distribution again, now with different stimuli inserted in these parts of the voice shape, but still recognized as these identities. But now we add this center or average distribution that people had never heard before during training. So this is something that they encounter new, not part of the training. And with this kind of setup, we can then ask the question, well, are averages abstracted when we form mental representations of voices? And a sort of strong, yes, averages are abstracted hypothesis would be that we would observe a test that accuracy of voice identity recognition would be higher for this average distribution than for the ring distribution. So it would look something like that, because if an average is abstracted, and that's what a mental representation is based on, then anything that falls onto that average should sort of be hitting bullseye basically, and you should be better at recognizing these stimuli from the average of these distributions. While we could also say, no, averages are not abstracted, and then we would be seeing that accuracy for the average is actually lower than for the ring distribution, because, well, we've never heard that average before, so why on earth would that be better? Let me show you what we found. You can see here on the y-axis accuracy for voice recognition at test, and then you can see the two distributions, average and ring distribution, and indeed accuracy for voice identity perception was better for the average. And I did not necessarily believe what I saw, because I ran the study, but that doesn't mean you believe in your hypothesis one, but we essentially did a replication just to really be sure with new stimuli, slight tweaks to the task, and also with obviously entirely new participants, and we replicated this effect. So we saw twice that the recognition accuracy at test for an average was better than for a ring distribution that was used during training. So from these data, we might see that listeners form representations when they learn voices from variable signals based on abstracted averages. And these averages are actually functional and are meaningful because recognition accuracy is actually higher for these averages. So it's not just something that hangs out in your brain as a mental representation, it helps you and facilitates accurate voice identity perception. But here's the thing about averages. We've just done away with all of the variability, right? If you average something, there's no trace of variability left. That you need an additional summary statistic kind of to be sure that you've encoded the variability. Because we know from the voice sorting study, if you're familiar with a voice, you can cope with variability. This study tells us that averages are abstracted, that's cool, but we've done away with the variability, so that's not the full story, right? People still need to represent the variability somewhere, somehow, in order to get this advantage in voice recognition when they are, or this advantage in dealing with within-person variability when they're familiar with a voice that we've seen in the voice sorting task. So that kind of begs the question, do we also encode or use variability actually at any point during voice identity learning, during voice identity learning? And I don't really have a direct answer to that question. I would really like to have one, but sort of a slightly roundabout way of addressing this question is to ask, can variability actually be useful at any point when we learn voices? And Emma has already previewed something here, so this is great. But the story so far essentially was that vocal variability was bad news. Either it threw people off and successful voice recognition became a challenge, especially if you were unfamiliar with a voice, or it got discarded in the last study, just gone. So what does that mean? In other fields, there's this, I guess, quite consistent finding that if you get trained to learn something via high variability training, then you learn better than when you're trained on something via low variability training. This has been shown for faces. Kay Ritchie has a great study on that, for vocabulary, and many, many more things in loads of other domains. There's a great text review by Limo Raviv that came out a couple of years ago. So we thought, cool, this is a way of testing that whether variability could also be useful at some point for voice identity perception. So, does high variability training make voice identity perception or help people when learning voices? The general approach here again is a training study, and listeners again did the study to be trained up to recognize a bunch of voices, and now they were trained up to recognize a few voices on high variability training and another bunch of voices based on low variability training. And then they were tested again at how well they could learn these voices. And if we believe the existing literature, where we find these high variability training advantages, then we should be observing that recognition accuracy would be higher after high variability training compared to low variability training. The way we sort of conceptualized or defined high versus low variability training was in the following way. In the high variability training condition, people learned a bunch of different identities based on stimuli that were sampled from different speaking styles. So a few recordings where people were just reading out the script, another few recordings where they were just speaking spontaneously with another person, and another bunch of stimuli where they were speaking really clearly so they could be well understood. Different speaking styles change the sound of your voice, increase the variability, the more speaking styles you have. For the low variability training, conversely, people were just learning voices based on one single speaking style. So one voice was learned via people doing read speech kind of stuff. The next voice might have been learned by people speaking clearly. And then the test stimuli that people encountered after training were also sampled from one speaking style, and the speaking style was crucially not included in the training. So there was no overlap in speaking styles, therefore hopefully not really that much overlap in sort of where these test stimuli would land in voice space, and thus there was some sort of generalization aspect between test and training. And here's what you find when you do that. Basically, in blue here, you see accuracy for high variability training, and in yellow for low variability training, and we find a high variability training advantage, which is great, and which is what Emma has also found. Nice. Here comes a big caveat though. This is one of 3 experiments that we ran as part of this paper, and these experiments included different kinds of definitions of high versus low variability in terms of how the training was constructed, and we played also around with how the training and test stimuli related to one another, because there's many different ways in which you can vary variability, and I don't think anyone had really done this in voice perception before, so we were just sitting there going like, oh wow, lots of things to do here, so we tried a few different things. And these high variability advantages, or this high variability advantage that I just presented to you, seems to only emerge when listeners need to generalize beyond what they had experienced during training. If, or in other settings, low variability advantages might, for example, arise, or there's just no difference at all between the two conditions. So if you think about how could low variability advantages arise, well, if you train someone on one speaking style and you test them on the same speaking style in the low variability training condition, while for the high variability training condition you sample lots of different speaking styles, well, the low variability training was lots more relevant in the end for then that particular test scenario. So that's how you can get a low variability advantage. So variability per se certainly affects how well we can learn voices, but what the direction of effects is, and if high variability is truly advantageous and helpful over and above low variability, well, the direction of effects really differ depending on the particular context you're in. So really, really intriguing stuff, but these high variability advantages can be quite quickly turned into low variability advantages. So can variability at any point be useful? Yes, under very specific circumstances. And that is the end of the first part of this lecture. Talk. And in study 1, which was a voice sorting study, hopefully you've seen that vocal variability likely disrupts identity perception from voices, especially when these voices are unfamiliar. We don't struggle so much as listeners when we actually know the voices, because we can now cope with the within-person variability that is present in voices. In the second study, I asked, so how do we actually form these mental representations that support familiar voice recognition from variable signals? And it seems like we form these representations based on abstracting some sort of average. I'm not saying that exemplars don't exist. People could still recognize the exemplars, obviously, for the ring distribution, but accuracy was higher for the average distribution. And in the final study, we asked, can variability in any way be useful? And we looked at high versus low variability training effects. And exposure to high variability training can certainly help us learn voices, but only when we need to generalize beyond what we already know from the training. Okay, second part of the talk. This is now going to be about person perception from voices. And so far, in one way or another, I have played my participants' voices and then gone, okay, then who is this person? That is sort of what all my research kind of boils down to. And when people were familiar with a voice, they were like, oh yeah, no problem, I can do identity perception for you. This is Aisha, you just trained me to recognize Aisha, this is fantastic. And that's what people were doing. But in the voice sorting task, when they may be not so familiar with the voices, they were going, you asked me who this person is, it's complicated, I don't really know what to do with this question. Now, that's what happens in my tasks. That's not what happens to us in real life. When we encounter voices that we don't know, we don't just go, here's a voice, I don't know that person, moving on with life. That's not what we do. What we instead do is something like this, what I call person perception from voices, or some people call it first impressions. We hear a voice, we don't know who that person is, and go, oh yeah, I was just talking to this young woman who was Welsh, sounded kind of nice and educated. That's the kind of message we take away from hearing unfamiliar voices in real life. And you have seen this word cloud before because you have put it up there. This is a word cloud from a study I ran where I just played people one voice, I think in this case, and just asked them, tell me something about the person. What do you think? Who do you think that person is? And you can see people have no trouble with that. So just to underline that point, people really hear a voice and they do their person perception thing. In fact, they form this quite complex and multivariate impressions of who a person might be like. So people comment on what they think the age of that person might be. They try to have a go at what the sex or gender of a person is. They like to guess where people are coming from. They spend a lot of words on trying to describe sort of personality trait kind of attributes. And they also really like to comment on sort of social status-y kind of social status attributes again. And yeah, that's what people do. Now, here is a sort of, I guess, a disclaimer. These impressions, some of them are accurate, right? We are quite good at determining the sex of a person. We can tell whether someone is an adult or a child, so we can do some degree of age perception. So some of these impressions can be partially accurate, but other parts of these impressions seem to be entirely subjective. There's not really any good evidence that we can actually tell from a first impression whether someone is, for example, trustworthy or not. So lots of subjective stuff going on that has no relation to a ground truth. In the first part of this talk, I dealt in accuracy. Everything was measured in relation to how accurate are people at identity perception. In this part of the talk, we're kind of doing away with accuracy because we can't establish accuracy for many of these different person characteristics, and these impressions still exist whether they're accurate or not. They influence our behavior, so we might as well deal with them as subjective percepts. So from now on, no more accuracy, no more links to ground truths. We're just dealing with subjective impressions now. But again, these are impressions that are highly multivariate. We hear loads of different kinds of person characteristics, or we infer loads of different person characteristics from voices when we hear them. So you might ask the question, are some of these different characteristics that we're perceiving there as the package of a first impression that we form from voices, are some of them perceived more quickly than others when we form our complex impressions? So for example, you could think that you hear a voice and you go like, young woman, great. And that's the first thing you get out in a few milliseconds. And then that, a bit later, things like social status or attitudes arrive in terms of your perception. And could it be then that the first impressions first impressions, the very initial attributes that you get out of a voice, could they basically facilitate or constrain the later ones, and then that sort of shapes how you sort of smush your different attributes together into a coherent impression of a voice? And to try to get at this question, try to work out how these different attributes might feed into this complex impressions, I asked, in terms of very first impressions, how much exposure to a voice do we need to form our very first impression for loads of different person characteristics? And the way I went about this was to run some sort of kind of perceptual gating experiment. So loads and loads of different listeners provided loads and loads of different evaluations of voices that were presented for different exposure durations, 25 milliseconds, 50, 100, 200, 400, 800 milliseconds of exposure respectively. So we have these different exposure gates where people hear a sound for a certain amount of time, and I go, hey, have you formed an impression yet? And they give me a response. And just to illustrate what these exposure durations sound like, here are 800 milliseconds. Loud 800 milliseconds. And we've got 25 milliseconds, so the shortest duration. It's short. You can kind of get that it's a voice, but you don't really get an awful lot out of it, which is kind of the whole point, because I want to work out, you know, when our first impressions really formed. While for the 800 milliseconds, when someone is saying a vowel for 800 milliseconds, you kind of heard everything about that vowel that you ever might want to hear. Good, so I need to tell you what person characteristics we had evaluated. Basically, there were 9 of them. Sort of broadly physical characteristics, sex, age, and health. sort of trait characteristics, attractiveness, dominance, and trustworthiness, the ones that are usually looked at and have been found as these like fundamental dimensions of trait space in voices and kind of faces. And then the more socially flavored characteristics of educatedness, how posh someone is and how professional they sound. You might ask, why these particular characteristics? If you think back to that word cloud that I showed you, these were the characteristics that were most frequently mentioned in these different kinds of social trait and physical categories. And if they're frequently mentioned, spontaneously mentioned by participants, we can kind of infer that these kind of characteristics are probably quite salient when we evaluate voices. So we really do form an impression of them when we encounter voices in the real world. And that's great. We now have loads of ratings data from loads of different exposure durations for loads of different person characteristics. But how do we assess from these data whether and when a person characteristic has actually been perceived or not? Accuracy is not the way forward here. I said that in my disclaimer. We can't really assess accuracy for practical reasons in many cases, like how do we truly evaluate how trustworthy someone is or how professional someone is. And where there is evidence that we can relate something to a ground truth, sometimes we just have chance performance. If you have chance performance, you can't really modulate that. So accuracy is not the way forward here. But here's an interesting thing about impressions. Impressions from voices and faces are to some degree shared among listeners. So that means that on average, listeners broadly agree to which voices sound more or less trustworthy, dominant, or attractive. There are individual differences. We heard a talk about it by Claudia, and last year we heard a EPS Prize Lecture on that topic in faces. So there are individual differences, and these are important, but we're going to focus in this particular experiment on the shared aspects of impressions. Because if impressions are shared, and listeners can agree on impressions, well, then we can use inter-rater agreement as an index of whether an impression has been formed or not after a certain exposure duration and for a certain person characteristic. Specifically, we would take high agreement as evidence that an impression has been formed, because people can't agree if they haven't perceived something. If they haven't perceived something, they'll just give random responses. Whereas no to low agreement, we would take as evidence in this case for an impression has not been formed yet after this certain amount of exposure. So with this setup, we can then sort of distinguish between, I guess, two broad kinds of time courses for how impressions of specific person characteristics are formed. We could see something like this, a rising time course, where on the y-axis here you see inter-rater agreement, going from 0, no agreement at all, to 1, perfect agreement, and then on the x-axis you see the different exposure durations that we tested. And if we see a rising time course, we've got no agreement after short exposure durations, and we very neatly in this cartoon sort of prediction go up to perfect agreement after 800 milliseconds of exposure. By that we then see that impressions are formed gradually over the time window sample. They're not there after 25 milliseconds of exposure, they are most definitely there after 80 milliseconds of exposure. And conversely, we could see something like this, a flat time course, where just inter-rater agreement is high, no matter what the exposure duration, 25 milliseconds, people already agree. From that, we could take away that really impressions are formed super rapidly. 25 milliseconds are enough for people to agree on something, so they must have perceived something. Let me show you what we found. Here are the sort of time courses of impression formation, split up into physical, social, and trait characteristics. And do I have a little pointer? I do. Great. So physical characteristics here. What you can see here straight away is that we, especially for sex and age, have these flat time courses. Agreement is high throughout. Doesn't matter how much exposure we give people, they already agree. So we would say, okay, apparently impressions for sex and age and health, if you ignore this weird little dink here, maybe even health could be perceived super rapidly, even from these super short little 25 millisecond exposures. Conversely, or rather not conversely, but as a different picture for, where's this thing? Oh God, I'll just point. Second one. Second one are the social characteristics. You can see here this rising time course. We start out with no to moderate inter-rater agreement, so not really formed an impression yet after 25 milliseconds, and then sort of steadily rise up towards good agreement, where after 800 milliseconds, we kind of have formed an impression. In fact, if you look at the two lighter colored greens, educatedness and professionalism, we're still going up. So I don't really know what people want to get out of a vowel after more than 800 milliseconds, but if I would have sampled longer time windows, we might have seen that impression formation even continues there. So quite a contrast between physical and social characteristics in terms of how much exposure you need to form an impression. And then we got the traits. The traits were not so well behaved, they're a bit messy. So what you can see hanging out here at the top, is dominance, and then you can see trustworthiness and attractiveness in order. I'll first say that trustworthiness and attractiveness, it kind of becomes a rising trajectory after 50 to 100 milliseconds, but something weird is happening quite obviously at 25 milliseconds of exposure. I don't have a super good explanation of what's happening here, but from digging a little bit into the acoustics and how acoustics contribute to these particular time courses, the thing is, for voice samples that are only 25 milliseconds long, the main acoustic information you get out of there is pitch. Pitch is relevant for attractiveness and trustworthiness judgment, but also other stuff. So if you only have pitch, you take what you can get. So people perceive pitch and go like, I guess this is highly trustworthy, and somehow end up on agreeing with one another based on basically impoverished signal, while then over the longer exposure durations, more different acoustic characteristics can be perceived and become online, and people are like, oh, I can actually hear a bit more, and then they slowly converge to using more acoustic characteristics to then eventually form their agreed impression on attractiveness and trustworthiness. That's way neater than the data actually looks, but I think that's kind of what might be underpinning this weird sort of moderate agreement for 25 milliseconds for trustworthiness and attractiveness. Dominance then. Dominance looks pretty much like a physical characteristic, and I should say the voices that are included in the studies include male and female voices. By social stereotype, males dominant, females less dominant. So if you basically smash them together, calculate the inter-rater agreement, you might just be picking up gender differences. Or so I thought. Then I and Mila actually split up the data by voice gender, recalculated the inter-rater agreement by gender, and lo and behold, for female voices, you see that you get a rising trajectory. So suddenly, female dominance impressions, they were behaving as we might have expected. But here's the thing, male dominance ratings continued to hang out at the top of the graph and had this flat sort of time course. And this is true across two studies, so this actually replicates. I do not have a good explanation for that. If anyone does have one, I don't know, but we've already seen in Claudia's talk, dominance likes to misbehave on occasion in studies of trait perception, so I'll just go, it's misbehaving and let's move on. So that's the study, and what do we learn from the study? Well, person perception from voices is rapid. 800 milliseconds of exposure, so less than a second of exposure, and often less, is enough to form an impression of all of these individual person characteristics when asked. Physical characteristics and dominance for male voices can be perceived from even minimal exposure. Most trait characteristics and social characteristics are perceived more gradually and need a little bit more exposure, but we're still talking everything kind of within 1 second, so still super fast. And that's cool. But there's another way of looking at impression formation and maybe taking less of explicit, here's a parcel of voice, can you evaluate that for me approach, where we can be tracking how impression formation works based on neural data. How does it work in the brain? When can we start tracking these representations of impressions from neural data? Specifically, by neural data, I mean an EEG study is what I've done. In this EEG study, people were listening to a lot of short recordings of voices, one after the other, 400 milliseconds of vowels for 1.5 hours. Happy participants was not what I had, but they were paying attention, they had an attention check to do, but that was basically what I've done. We played them a string of voices and recorded the EEG data to work out what the brain made of these different voices. And then after they had their 1.5 hour EEG session, they were doing also a behavioral task where they, much like in the previous study, then just went into a behavioral session where they gave us behavioral ratings for all of the voices they heard in the EEG experiment, for all of the different person characteristics that we had in the previous experiment. So we've got now neural data for what the brain makes of voices in a sort of implicit way when people are not giving me explicit judgments, and the behavioral data where I collect what people actually thought about these voices. And if I can relate them to one another, I can track how these person characteristics are reflected in the neural data. Now, neural data, behavioral responses are quite different kettles of fish, so how do you relate them to one another? And I did this via an analysis called representational similarity analysis, RSA, where essentially you just create something called RDMs, representational dissimilarity matrices, that index essentially how dissimilar each possible pair of voices is that were present in a study. You do that based on the EEG data, and EEG data is a time course. You do a neural matrix for each millisecond of measurement based on the electrodes, and you do that for the behavioral data where you just take the behavioral rate and go like, hey, how dissimilar are you? And you create your dissimilarity matrix. And then you have your two RDMs, the neural and the behavioral one, and you can relate them to one another by doing a correlation behavioral matrix with every single time step in the EEG analysis, and that gives you a time course of, well, kind of impression formation in the brain where on the squiggly line, these are correlation coefficients, and of the behavioral RDM and the neural RDMs across time being correlated. And if these correlations are significant, we can kind of infer that the person information from the behavioral matrix is represented in the neural data because there's a correlation, so there's shared information. And so at that point in time where we find significant correlations, we would then say, cool, the brain represented, I don't know, age at that point in time after stimulus onset. And if you do that and a bunch of analysis, you get lots of squiggly lines. I'm not going to go through all of them. Don't worry, I'm going to give you headline sort of patterns that you get out of these particular, out of these particular analyses here. So, first thing, when we just correlate a behavioral matrix with all of the different milliseconds of the EEG signal, we find significant correlations from 80 milliseconds after the stimulus started. So you hear 80 milliseconds of a voice, and each and every single person characteristic, all of the ones we measured, are basically represented and correlate with the neural activity. And I was kind of surprised at finding so many results. So I was like, okay, what happens actually if you do this correlation with a behavioral matrix and the EEG data? What explains the variance that we account for with this particular model? And we know voices are made up of acoustics. So you might be asking, okay, how much of this correlation and these representations that we can see are actually explainable by stimulus properties, by the acoustic properties, and how much is actually a more sort of higher order representation where people have actually perceived, say, gender as opposed to high and low voice. So you can basically, instead of doing a correlation between the behavioral matrix and the neural matrix, you can now partial out all sorts of acoustic properties and thus get yourself a time course of person perception. Can you get yourself a squiggly line that basically has acoustic contributions kind of partialed out. And if we do this, we still find that each and every single person characteristic that we tested is represented from 80 milliseconds after stimulus onset. But here's the crucial thing. If we compare that time course with the one that we previously had, where the acoustics were not partialed out, we can see that the time course where the acoustics were partialed out and the one where they were not partialed out differ from one another between 80 and 300 milliseconds after stimulus onset. So that's the time window when my representations that I'm picking up are still sensitive to acoustic properties. After that, they become invariant, so we can say this is sort of a higher order kind of representation that happens. And by invariant, I simply mean that these two lines then are not significantly different from one another anymore. So that is well in line with other models of acoustic and sound voice processing. We've got these earlier stages of stimulus-bound processing, and then we've got later stages where the voices or whatever you're processing become processed in a higher order way according to, I don't know, the emotional content or the speech content or the person characteristics as we see it here. Okay, next step. We've got all of these different person characteristics and various talks across the EPS meeting this time. People were, and several posters actually, people were alluding or showing results that person characteristics are not really ever perceived independently of one another. So if you just take mean ratings per voice and correlate all of these mean ratings across the different personality characteristics that are measured here, you get this correlation matrix out where you can see basically everything correlates with one another quite highly. And like I said, this is the case for this particular stimulus set and any other stimulus set I've kind of looked at. This is the case for faces as well, and for conceptual knowledge, all sorts of things. Person characteristics are highly intercorrelated. But because we can and because it's actually an interesting question, what happens if we also account for all of these intercorrelations? Because currently what we're mapping is we've taken the acoustics away, but we're still looking at representations that have intercorrelated person characteristics in them. So, well, what then are we actually measuring? We're measuring this like complex intercorrelated stuff. Can we look at something much more neat in a way, and can we look for independent representations of individual person characteristics? So can we look at something that, for example, if you have a representation of age, when we partial everything else out, we get a representation of age, an age impression that cannot be explained by anything else, not by the acoustics or any of the other person characteristics that we measured. This is a quite artificial thing to do because this correlation between traits are real. That's a feature of person perception. But nonetheless, I guess it's still an interesting sort of theoretical questions of whether independent representation of individual traits can be tracked down. So what happens when we look at that? We find independent representations of sex and age quite early on, between 80 and, well, pre-150 milliseconds after stimulus onset. And we find independent representations of dominance, trustworthiness, and professionalism a bit later on, starting after 350 milliseconds after stimulus onset. Nothing remains for representations of health, attractiveness, and attractiveness, which just again hammers home this point that if you account for a bunch of person characteristics, well, they're intercorrelated. At some point, you've mopped up all of the variance, so these intercorrelations are like powerful, basically. But if you want to think back to the previous study, the behavioral study, well, what we saw there was that sex and age, and maybe health, were perceived super quickly from very little exposure, and these were also the ones where we now find independent representations early on, while other stuff, not dominance, it's not quite as neat a picture as I would like. Other stuff was perceived later on and needed a bit more exposure, and we find the independent representations of some of these characteristics a bit later on. So is there again evidence for this like staggered time course where physical stuff happens early and other stuff happens maybe later? Wouldn't call it super strong evidence, but at least it's some sort of, you know, intriguing notion of what this kind of analysis has basically just shown. But the main message of this, partialing everything out in this pink line, is really that person characteristics are perceived in an interdependent manner. Independent representations are something quite strange to really look for. So, end of part 2. How am I doing for time? Oh, quite well. Person perception for voices. This is what we just looked at. We very, very, very quickly form an impression of a person based on hearing a voice. And these impressions do not need to be accurate. They exist. Some of them are accurate, some of them are not accurate. We always probably believe that we're right, and that's all that matters because we will act on these impressions that we form. We need, in fact, less than a second of exposure to form these impressions. And we indeed find in the brain, in EEG data, evidence for these impressions being represented after only 100 milliseconds of hearing a voice. But impressions are really highly intercorrelated, which might be down to all sorts of things, like halo or overgeneralization effects, where you just like perceive one thing and you just go, oh yeah, the rest will just fall in line according to my, I don't know, social stereotypes or whatever else I have. Or maybe I'm just asking people to make judgments at a level of precision and well-resolved kind of I'm asking people to make decisions at a level of resolution that they just don't have. If I'm asking them, hey, can you tell me the difference between whether someone's educated or professional, they're just like, meh, both the same to me, so yeah, I'll give you the same rating. So I don't really know where these intercorrelations quite come from yet, but you know, there's a lot of work that suggests or has potential mechanisms or has implicated potential mechanisms. Now, just to wrap up fairly briefly, I hope I have convinced you that when we hear a voice, we hear a person. There's never a moment when we hear any human voice and go, a voice, goodbye. We just do get so much more out of voices. We get a full impression of who that person might be. And I started this talk by saying I like to study voices because they're these really rich and complex signals that give us so much information. Here's another thing for why I like to study voice perception. There's so much more to do. It's a small field in the end. There's not many of us. And basically every time I sort of take one step to the side, I'm like, ooh, new interesting stuff to do. So much more to find out. Here are just some things that were at the top of my head when I was doing these slides of what we actually don't really know, of just big questions that we know not enough about, like all of the work, is this right? In the symposium, we were all dealing with fairly typical listeners, just people we got off the internet, and that's great. Many people are typical listeners, but there are also people who perceive voices in different ways. They might have some form of hearing loss or something else. We don't really know how voice perception, voice identification, and person perception from voices works with them. There's a lot of work on how they understand speech, and it's understandable. People want to understand speech. That's the most important thing possibly that we get out of a voice. But the social information, the personal information is also relevant, and there's very little research on it. Similarly, all the voices I think we were all studying so far were typical voices. There's plenty of people who don't have typical voices. Actually, you had atypical voices in there. Well done. But yeah, atypical voices. There's loads of people with voice pathologies, with stutters, with voices that are just not falling in line with a typical voice. We don't really know how they are perceived by others in so much detail. And, well, there's loads more. What about development? There are children. How do they do voice perception? We don't know. And also, more recently, I think Christina was talking about it. What about AI voices? I started this talk also saying, oh, a voice comes out of a body. Well, not necessarily. Now we can just synthesize voices and create voices to induce impressions in listeners. What does that do? Like, does perception of AI voices work in similar ways to real human voices? Perhaps. You might give us some work very soon on that. That's great. But yeah, so much more to do, and I could be probably going on forever about what else needs to be done. But I'll just stop here and say, well, thank you very much for listening, and I should also say thank you to all of these people who in some way or another worked with me on voice perception studies, and there's many more that didn't fit on here, and none of this work would have been possible without them, so thanks to everyone. Thank you.
Well, thanks very much for a brilliant talk. That was fantastic.
Thank you.
I could have listened to far more. It seemed to go very quickly for me. I don't know about you guys, but it was just fantastic. So thanks very much. You're under no obligation at all to answer any questions. You can just go straight to dinner if you want.
It isn't served until 7, is it? So we've got a little bit of time.
Okay. Good.
Okay.
Would anyone like to ask a question?
Thanks. That was brilliant. I absolutely loved it. I was really interested in your stuff about initial impressions, and in particular, when you introduced it, you were talking about how initial impressions can constrain later impressions that you form.
Yeah.
And I was wondering about how kind of fixed and unidirectional that would be. So, like, if you took somebody who had, for one reason or another, a belief that men can't be trustworthy, and you played them a voice which at the beginning is the pitch of a male voice.
Yeah.
The brain would say, okay, it's the male voice. So in theory that should block their trustworthiness and impression that
Yeah.
comes a bit later. But then you morph the voice into like a trustworthy female voice.
Okay.
Are you able to go back and believe it's trustworthy or not?
Well, good question. Need to do research on that because I don't have an empirical answer. But what I would guess is when I was talking about how these first impressions are formed, I was talking about individual person characteristics morphing into a first impression. I think what you might be suggesting here is something where someone forms a first impression going like male, not trustworthy, but then the voice changes, you get more information, and you would then update your impression and go, oh, hang on, I got that wrong. Female, trustworthy. So it's like that's basically going from a first impression, a very first impression from the least possible information to actually already a second impression where you then would reevaluate. So I don't know what someone would make in terms of misperceiving gender, because we're really quite good at perceiving gender from the voice. But yeah, I think that's a question of first impression with a second impression following, where we've updated the impression and not a first impression formation, because your male trustworthy is your first impression, female, male untrustworthy, female trustworthy is a second impression already. Does that make sense? Yeah. Cool.
I really enjoyed the talk. It certainly convinced me that I should think about voices much more than I currently do.
Talk to me.
But I'm thinking about the first part of your talk, we were talking about variability and learning and familiarization. So I'm very interested in that whole magical process of going from not knowing something or not knowing someone to knowing someone. And you convinced me, and this fits, other work and places, things like that, that variability is useful. I guess my question is, how much variability? So for the most part, most of what you were talking about tended to categorize or conceptualize variability in a kind of binary way. That sort of thing.
Yeah.
Do you have any intuition about the answer to that question? And in fact, is it even answerable in the first place? Because at least in face perception, it's a bit of a nightmare. But maybe you could, this day, might be able to.
I have to disappoint you, I don't have an answer, but I guess the main problem for answering this question is a prerequisite to define how much variability there specifically is, right?
Yeah.
To quantify variability in an objective way is a nightmare already.
Okay.
It's like, where do we start? Acoustic measures, perceptually salient acoustic measures, only perception. In my studies, I've taken sort of a logical approach to increasing or decreasing variability. I don't actually know how much different speaking style increase the variability relative to one, but by logic, 3 separate things are more variable than another. I cannot quantify this for you. There are engineering approaches that can quantify the acoustics beautifully, but how does that relate to perception? So I think the answer to your question is, we don't really have a good way of quantifying variability, therefore we can't really parameterize it, therefore I don't know, but I do certainly believe that especially with limited exposure to a voice, there can be too much variability, where it's just like everything sounds completely mad and you can't really tie it together to coherent percept, and you just like, you will never learn. So there was, in the high variability training study, there was one condition where, oh God, what was it? We manipulated high versus low variability by showing people either from different speaking styles, lots of different examples, or a smaller number of repeated examples, but all from this high variability context. And the small number of repeated examples were not enough for them to learn at all, because they just didn't get quite enough information. So that's maybe a hint at there being something like too much variability for the time frame of learning. Does that kind of answer your question?
That's very interesting.
Yeah. Yeah.
So I'm not a very strong voice person, so I might ask something that's very, very doubtful. But thinking your 2 bits of your talk, I guess we are making first impressions from a voice, but actually functionally what we're probably trying to do most often with a voice is work out who it is, right?
Yeah.
And so all those different characteristics that are coming in at different times, presumably they should be the things that actually allow us to identify facially people. And so the stuff that comes in first is the stuff that's more informative. But are those characteristics useful at all in distinguishing faces?
So are the voice characteristics?
Yeah.
Ooh, Harriet? Oh, Harriet's gone. Basically, are they? So we had a talk earlier. I don't know if you were there for Harriet Smith's talk. Were you? Yeah. So it was like face-voice matching. It's like, can the information from voices help face recognition? Otherwise, there's debates about whether there's any concordant information really at all. There's some, but not others. Is it used? Basically, the answer is, I think, while face and voice perception often work in parallel to one another, and while sometimes they are super additive, often the voice information just kind of gets ignored when you have the face. So that would be my sort of guess answer. Does that answer your question, kind of? Yeah. Ooh,
Okay, just
sorry.
one more question. Is that all right?
Okay.
Yes, and then other people can nab you afterwards.
Thanks, that was a lovely talk. In the work you presented on the time course of, like behavioural time course of perception, you're looking at agreement across observers, but could you also look at self-agreement?
I had one presentation per stimulus, so if I had run the study differently, yes, it would have been possible, right? Because if
do you think it would show the same time course?
Let's run the study. I don't know. I would say that for all I remember, and Mila, correct me on this, when we did little bits of intra-rater agreements, so we had two presentations of the same sound, just took a look at how well these ratings correlate. Correlations were not brilliant in general. So there's like a question of like, how much intra-rater agreement is there per se, and would it be enough to really map out this time courses particularly well? I can't now remember how high the correlations were. As long as you have some sort of correlation, you should be able to measure from 0 to whatever that high point is. But yeah, I guess.
It was a lot higher for men than for women. No, women agreed.
Oh God, yeah, there was this weird effect. That's true. Yeah.
And it was straight away.
Yeah, that's true. So basically the answer to your question is, I think for intra-rater agreement, the agreement is just in general a bit lower, at least in terms of how we measure it. So it's possible, but the measurements would be just noisier throughout, basically, if that makes sense. Yeah, cool.
Great, thank you very much. I think we should all thank Nadine again for a brilliant talk. Thank you very much. It starts at 7 to 45, something like that.